So we call something called surface detection using deep learning. Okay, what I am going to do is yesterday you might have understand what is machine learning, what is deep learning. So there are two kinds: machine learning, deep learning, reinforcement learning. There are three categories. Okay, so deep machine learning is based on smaller data sets. Smaller data set. Best one in machine learning is regression and correlation. So correlation is correlation of two variables. Regression is predicting one variable when they given the other variable. So prediction based on mainly on regression. Okay. So if you have one independent variable, one dependent variable, we call it as single regression. If you have multiple independent variable and one dependent variable, we call it as multiple linear regression. One good example is age is one factor. Ethnicity, Asian, European, American is another factor, and smoking habit is another factor, drinking habit is another factor. If based on these four things, I could be able to predict the person may get a blood pressure or not. So getting a blood pressure or not is a dependent variable, but these four will be the independent variables: age, ethnicity, smoking and drinking. Okay. So in this case, what the equation says: y equal to a1 x1 plus a2 x2 plus a3 x3 plus a3 x4 plus b. B is the bias. This is multiple linear regression. Most of your problems in the world can be solvable using a multiple linear regression. This is machine learning. Data set will be in Excel sheet or comma separated values. You can train it and you can get it. Okay, get the patients of 40 patients record and give your data. It will tell you whether you get a BP or not. If you get go to Apollo Hospital, get all the records of 40 lakh records for over the 25 years and check it. The accuracy is very good. This is machine learning. Deep learning is and I am laughing. So many neurons are activating in my brain. The neurons makes now this action. Some neurons are being activated. Lakhs of neurons, crores of neurons activated. Now how do I emulate a neuron in a mathematical formula? This we called as a neurons together join it and based on some actions will be taken care. This is called as deep learning. So one neuron to another neuron, we go for it. So for example, I have this is one neuron. This is another neuron. And this is another neuron. This is another neuron. Now when you see that from 3 to 5 like this, the line goes from here 3 to this plus 5 to this. That means if you want to traverse the neuron from this value to this value and this value to this value, add this into this plus this into this. That will be the addition and multiplication operation in deep learning. So crores of multiplication addition operations need your resources. For that, a normal CPU will not do that. We need to go for a GPU. GPU, you heard about it? We have all of you have a laptop with you. Many of you have a laptop with you. A laptop with the GPU is there or GPU is not there? If GPUs are there, you can train your model based on this. Okay. Now, for example, I am Pradeepkumar. Sir, your name? Hariharan. Let's say I want to create one new Hariharan. Suppose he is of 20 years old. Okay. I want to replicate 20 years old of one more Hariharan here. What should I do? Cloning. So I can able to physically clone him. Okay. But how about his brain? I need to get the same thoughts what Hariharan is having. That means whatever Hariharan has been learning for the past 20 years, I need to get the model. I need to train it on a new machine learning, deep learning model, and then feed it back. So in that case, for 20 years of data, if I want to get it, the entire world resource is not sufficient for me. I need to have huge amount of GPUs to train what Hariharan has been going through in the last 20 years, which is a very powerful task. Okay. Now this is where deep learning comes into picture. So deep learning is training the model. We are going to train the model. This is what deep learning. Deep learning is mainly on neural networks. Machine learning, no neural networks. Deep learning is neural networks. What is reinforcement learning? Reinforcement learning is the third kind of learning. Suppose let's say a person entering inside. Okay. Now he is just shouting. When he come outside, he is shouting and then coming inside. When the atmosphere is calm, what he will do? When everyone is calm, he is shouting outside and come inside. What he will do? Once he enters this room, he will say, okay, something is going on, let me be quiet. How he learns that? through the atmosphere. So this is where reinforcement learning works. This we call RL algorithm, reinforcement learning. Okay. One good example is a small 3-year-old baby. A mosquito is biting. What the baby will do? The mosquito is biting a baby of a 3-month-old year-old baby. What the mosquito, when the bite, what the baby do? It cries. 3-year-old baby. 3-year-old baby, same old 3-year, and the baby is 3 years old and mosquito is biting. What the baby will do? The baby will try to shake his hands or try to hit it. Okay. If it is a 7-year-old boy or girl, I mean, chasing that the mosquito and then kill it and then come back. How it happening over the years? Reinforcement learning. So if you want to make a system to be trained in an environment, put the variable into the environment. The variable learns itself. That's what we call reinforcement learning. So we are all into reinforcement learning. We are all reinforcement learning pupils because we learn from the environment. Okay. So you might have seen some students are very good in schools, but when they come to college, they are not performing well. You know, some are very average in the school, but when they come to college, they excel like anything. How it is happening? Because of the environment what they get in the schools and the colleges. This is how reinforcement learning works. All these three models, deep learning needs data. Machine learning needs data, but reinforcement learning data is not needed. Machine learning, the reinforcement learning data is not needed. What is the data? I need to train on the data. Okay. Now today I am going to show you an example. Let me show you that. No. Only demo. I'll explain in the meantime. Okay. So I have used NEU, AU, Anna University. I have just used it. I have a data. So I've heard about these things: grazing, inclusion, patches, pitted surface, rolled in scale, scratches. These are all some of the. So I'll show you what is grazing. So grazing is a kind of a surface detection, surface defect. Okay. So this is what grazing looks like. So I have seen that totally these many grazing samples are already been there as a data set. Okay, image data set. So totally how many images? 240 items there. So totally 240 images on grazing. Okay. Next one is inclusion. Inclusion is, this thing is inclusion. Okay. So again inclusion also 240 data. Okay. So you can see inclusion also control level is 240 items inclusion. Okay. Next one is patches. So you can see we are telling patchwork now. When during the rains, when the roads have potholes, what the roads will do is, because of the pothole, the corporation people come and close it up. So we call it as a patchwork. So you can see it is uneven there. So they put the tar and other thing and then patchwork. Okay. This also we have totally around 240 items, 240 images. Next one is pitted surface. You can see this is the pitted surface. So all these things happen in the concrete structure also. In concrete structure also all these things are happening. So now this is the pitted surface. Okay. Again this is also 240 images. Rolled in scale. So this is rolled in scale. Okay. So this rolled in. Okay, scale. Next one is scratches. You know that scratches in the surfaces, either you can take a knife and then scratch on the wall and then capture it. Okay. Now one assumption here is I have taken all your mono. Mono means white and black images. I have not done any coloring images because coloring images need more complexity. So for understanding purpose, first I made it as a mono. Mono is white and black and white. Okay. So now using these 6 kind of training, I'm going to train my model. What is the model will do is, let's say, assume that the application, an engineer is there, like a civil engineer. Okay. You are having a handheld device, probably a phone or a handheld device. What you do is, you just open your camera and then take that picture and then check it, what kind of surface defect was that. Once you see that and then process it, already have trained the model. Pre-trained model, we have something else pre-trained. I'll tell you what is it. Pre-trained model is already there. Now that model will say that this is 93% rolled in scale, 2% or 3% in scratches, and 1% in grazing. Okay. Now 93% it was a rolled in scale. In the case, what he says, okay, this defect is rolled in scale. Then what should I supposed to do? Okay. This is where you can able to find out using a mobile phone. But further, what you need is I need a data set. Data set is already there in form of 240, 240, 240, 240, 240. Totally 1440 images already there for training the model. First, I am going to train the model. Okay. Now, generally in training the model, we have in deep learning we have some parameters. We generally call hyperparameters in deep learning. See, when you start learning deep learning, if you already learnt it, those things will be, I will make it easier. Epochs. First thing is epochs. You heard about epochs? You had any day scholar, all day scholar or hostlers? Day scholar, anybody there? Ma'am, from which area you are coming? Huh? Area. Oh, so other part, okay, good. So she is coming from Kilambakam. Kilambakam is near Vandalur. Okay. So now Kilambakam to Anna University. Now when she is coming, now ask her, give a task. What is it? Whenever you are coming from Kilambakam to Anna University, on the right hand side, count the number of trees. Count the number of trees when you travel from Kilambakam to campus. On the right hand side, because we have both the sides. I want to, for easier purpose, I am telling her count the number of trees in the right hand side. Okay. When she come in the morning from Kilambakam, she count the 1, 2, 3, 4, 5 like that. Okay. But what I am telling is first level trees. Suppose I have trees like this. We have second level, third level also. Became 4 trees. But I am telling only first level trees you count it. I am telling her. Now when she come, then first day, she is telling, sir, it was around 330 trees. She was counted. Okay, 330 trees. Okay. Then I am telling, okay, today when you go in the evening, you sit in the left hand side. Because morning she shared in the right hand side. Now I am asking evening to go in the left hand side. Why? The same number of trees she can count from Anna University to Kilambakam. Now she is counting. Now when she go there, it was telling 334. Morning it was 330. Now it is 334. Is it possible or not? Is it possible or not? Is it possible or not? I cannot blame her because maybe morning she might have missed some count. Or evening she would have, by the time she respond to something and then when she see 2 trees have gone, she make, okay, I will take plus 4 extra. Might be she might have done it. So, coming from Kilambakam to Anna University is one epoch. Going from Anna University to Kilambakam is another epoch. Like that. Again, next day I am telling that you go for 10 days, count the number of trees. Second day she is coming, third day she is coming, fourth day she is coming. Again going also. So 5 days she did how many times? 10 times. So 10 epochs. Now take the average. 330, 334, 1 day see 328. Finally take the average. I see the 329. So 329 trees are there. I can conclude it. So after 10 epochs, my accuracy improves. This is called as epoch. Epoch means what? In deep learning side, going through the data set completely one time we call one epoch. No, not enough. I am going the second time. All the 1440 images, I am going for the second time. So completely another epoch. No, third time, completely another epoch. Fourth time, completely another epoch. Like that, this is called as epochs. Okay. So whenever you heard about what is epochs means, this is what epochs. Epochs means traversing the data set completely for one time. We call it as epochs. But please remember, now I am giving 1440 images here. You may have 10,000 images also, or you may have 1 million of images also. Traversing through all 1 million images also one epoch, but the time will be taking more time. Okay, this is epoch. Next thing is activation function. We have something sigmoid. Something. Okay, activation function. We call ReLU, rectified reliability. So URL civil. You studied any paper on electrical? Did you study anything on circuit? Any one paper on basic electrical? You know what is a AC-DC power supply? How you convert AC to DC? Transformer. Okay, what is the name of the device name? Converting AC to DC. We call it as rectifier. Rectifier. What is the purpose of rectifier? Okay, this is engineering concept. So sinusoidal waveform, you know, right? Sinusoidal waveform. We have a positive and we have a negative. If you remove the negative, we get a DC waveform. What is DC waveform? No zero. It never comes to zero. It will be always in the top. Okay, in the high range. So we call AC to DC. We call it as rectification. Here, rectified linear unit. because generally in some models we don't need a negative values. In models like deep learning, we don't need negative values. Okay, in that case, we go for a rectified linear unit. Okay. Now, for example, if let's say something, if I'm just throwing it, what is the motion of this? When I throw something in the air? Projectile. What is it? Projectile is okay, fine. When I throwing, the action of throwing is projectile, but what it goes? If I want to equate that into a graph, what kind of graph you will get? Good. It's a parabola. Okay. Sigmoid function is, we have a positive parabola, we have a negative parabola. You get a S like this. Sigmoid, yes. Sigma, yes. Okay, that means we have a positive, we have a negative. So activation function is, when I want to train my data set, what kind of data set do you want to use? You don't want to have any negative things, then use ReLU, rectified linear unit. What is linear unit means? What is y equal mx plus c? Y equal mx plus c. See, linear line. But negative, is anything there negative? No. Rectified linear unit is, you have only positive axis there. Negative will be 0. This is what ReLU or what about. What is y equal to mx plus c? What is m and what is c? M is slope. C is intercept. Okay. Slope means what? The same way it goes. Intercept is the same line can be goes like this, like this, like this, like this. This is intercept. Slope is this line. Okay. So this is what single linear regression. What is x there? Independent variable. Why there? Dependent variable. Got it? This is single linear regression. Okay. Now rectified linear unit is almost a linear regression without any negative axis. Got it? This is the next one is the hyperparameter activation function. On what basis you want to activate the function? Number 3 is batch size. Okay. Number 3 is batch size. Okay. Batch size is okay. Now let's say my hand, okay, you are pouring, let's say amount of rice or amount of data you are pouring in my hand. How much I can hold? I have some, so every hand is not same, okay. So suppose you have a bigger person, bigger than me and coming and standing and getting the data, their hand may be bigger enough, okay. But in my case, my maximum capacity is 128 for example. Only 2 power, batch size is only 2 powers, 128, okay. But 64 can, 128 is the maximum size. Can I handle 64? 32? 128 is maximum, but 256? Not possible. Okay, now the data set also, whenever I want to consume the data, because I have 1440 images, I am saying that the 1440 images, I can able to hold only 32 at a time, or 64 at a time. That means put 64, the next 64, the next 64. I do everything in a batch size. This is called as the next hyperparameter called as batch size. So if you use 32 or 64, actually the minimal, if 32 is there, it's a minimal one, okay, and 128, or it can be 1024 also, or it can be 1024 or more than that also, based on your huge volume of data. If I have 1 million data, 10 lakh data, can I use 32 at a time? 1 million data, I want to use 32. When did it get completed? 32. In that case, what I go for 1024 or 2048. Okay, got it now? So based on the data set size, you can make the batch size to be increased in powers of 2. This is the next hyperparameter. Okay. Fourth hyperparameter is optimizer. Anyway, optimizer I don't touch upon now. We have these two optimizers. Gradient descent. Okay, now I ask you one question. You are good in differential equations, right? Or calculus. You studied calculus? Yes, okay. Now, x power 5. What is the differentiation of x power 5? 5x power 4. Okay. Now I have a gradient is like this. I have a bell curve. Something like this it is there. This is x power 5. Okay, I'll show you that also. Okay. 1 minute, I'll take my internet.
need Ethernet.
Not Ethernet. Or directly internet will come up. Just wait. I think it is coming. Yeah, it is coming. Okay. I'll show you this also. Okay, right. Plot x power 5 plus 3 into x power 4. Okay. We'll get a waveform like this. Okay. Right. Just wait 1 minute. Into LW 5. You get this is x power 5 plus 3x power 4. Okay, this is the waveform. Now I am differentiating this. I am telling one optimizer because I am differentiating this. Okay, now I am closing this. What value you will get for differentiating this? X power 5 becomes? Okay, now what I do instead of this 5 into x power 4. So 5 into x power 4. Okay, and this here 3 12 x cube. Good. Now the waveform completely changed like this. Okay. Now see that it was earlier like this. Now it is changed. Now what else next? 20 x cube. Okay, plus 36 x square. Okay. Now I think recollecting all your mathematical formulas, right? Good. Okay, now you can see again it comes back with the same value. Okay, right. Now this also fine. Now again one more time. What next? 60x square. Then 72 x into x. Now what is this? X square plus x. X square is what? Throwing the stone. Parabola. Projectile, the function of projectile is parabola. Okay. Now parabola is done. Now what next? 120x plus 72. What is this? Y equal to ms plus c. So we got the line here. Now what is the final one? Not final. One more thing. 120 na? Okay. So now in 120 the gradient descent is almost constant. So what happens when I train the model? After 5 differentiations, my model becomes like this. But that should not happen. The learning should always be there. What should I do then? Integration, good. But integration again the reverse way. There is unlearning or something. So I need to check a variable that should not deteriorate over time. What can I do then? X power 25 infinity. Then in that case, what I do? What is this? exp of x. What is that? What is the differentiation of e power x? E power 2x, 2e power 2x. Then again into that. So the gradient never gets to descent. It never come back to a straight line. So that means the learning will be keep on happening. So we are all exponential human beings because the learning is there till our death. We learn. Somewhere or other somebody will teach you, but we should not be a straight line. Okay, got it. This is called as gradient descent SGD. It's kind of an optimizer. So if you give SGD, the learning never stops. But accordingly, you have to take the variable names. Okay, for that only I just showed you this x power 5 onwards. Because x power 5 is okay, fine. But e power x when you take, always the learning will be there. Okay, right. Now, fifth parameter is number of hidden layers. Now, let me show you one example, a small example. Okay, now this is what on hidden layers example. Okay, I'll take the image. Okay, you can see here. Okay, now let me explain you this. This is what deep learning all about. Okay, so I have a visible input layer. Input layer is this is where they are giving the input, and here this is a visible output layer. Output layer is number of classes. What we call the number of classes. Okay, now let's say you are writing your phone number 1, 2, 3, 4, 5, 6. We write 1 like this. Somebody write 2 like this, 3 like this. I want to detect the numbers. In that case, 10 classes here. 0, 1 class, 1, 1 class, 2, 3, 4, up to 9. 0 to 9, we have totally 10 classes. That's the output. But what is hidden layer is? Hidden layer, this is what? So in the hidden layer, this into this, this into a weight plus this into the weight plus this into this weight will be equal to this value. So if you want to compute this value, how many lines? 1, 2, 3, 4 lines are connected, right? So this value equal to this into this plus this into this plus this into this plus this into this. This is one hidden layer. Now how many nodes are there in the hidden layer? As per this example, 4 nodes are there. But we can have 128 nodes. We can have 256 nodes. That means for 4 nodes, you tell me 4 nodes connected there. So this into this plus this into this plus this into this plus this into this. How many addition? How many multiplication? For computing one node, this into this. That means one multiplication. This into this. Next multiplication. This into this. One more. This into 4 multiplication. How many additions? 3 additions. 3 additions, 4 multiplications. How many operations totally? 12 for one node. 7. Okay, 7 for one node. 2, 3, 4. 28 operations carried out for one hidden layer. Add one more hidden layer, the number of complexity keep on increasing. But think about 128 nodes, 1024 nodes, 256 nodes, the complexity increases. So this is where your deep learning needs computational resources. CPUs usually they won't do this much task. It will do, but I'll show you that also. How slow it is doing. Okay, so this is where the next one is number of hidden layers. More the number of hidden layers, the more complexity the training will be. But accuracy is good. Because my weight will be improved like anything, so my accuracy is very good enough. Okay. So this is what my next, but there are so many other parameters also we have. But anyway, I'll just stop it here. Okay. Now these are the parameters we call it as hyperparameters in deep learning. So varying these parameters will make your learning better. Learning and training the model will be very good enough. Okay. So now I will go into code. So CD. So I have 2 models here, train model.py, a Python file, and I have an application.py. So application.py will be a browser based application where I will be downloading the these images I will take. I will take these kind of images. Okay, this I will take. And training the model, we have a Python file. So you studied programming, Python? Okay, but I will explain you the concept. Okay, so I will explain you the concept. So number of epochs, how much I have given? Now you know what is epochs? All of you know epochs, right? What is epochs? So now 10 epochs, it takes more time. I will take 5 epochs for the, because 10, another 15-20 minutes. So I will take 5 epochs. 10 epochs takes more time. Okay, because my laptop doesn't have a GPU, so it takes more time. So 10 epochs. Batch size I have given as 32. So let me use 64 here. Number of classes, 6 classes. Why 6 classes? Tracing, rolled in surface, pitted surface, scratches, and the other 2. Totally we have 6 type of. So output classes and number of classes are 6. Where do I have the data set? So the data set is there in the NEU data. So you can see outside we have a folder called as NEU. Just wait, I'll show you that folder. Okay. So this is my NEU data. You can see home, NEUA, NEU data. In this directory I have all the images. Okay. Right. So this is what I am going to try out, and I am going to train this model. So optimizer, you can see I use Adam optimizer. So I told you the gradient descent and the Adam optimizer. So here I am using by default Adam optimizer. Okay. So actually this code you need not write by yourself. Even using LLM, ChatGPT, other thing you can take the code. But only thing is you understand the concept and you take the code. So far now you never forget what is an epoch, right? You never forget what is a batch size. Okay. So I made you understand how really the deep learning works. Okay. Right. Now I will be training the file Python train model.py. Oh sorry. Okay, so wait for some time till the algorithm. Till the training process. Now I am going to train the model. Train the model means what? What is the training the model? Going through tracing, reading the image number 1, image number 2, image number 3. Like that, we have totally all the 140 images, 240 images. It read. Then again come back. Go to the next folder. Open that image. Learn all the 240 images. Next folder. Like that, all the 1440 images it will read. Read means it will train. Now let us see. In the meantime, let the training process goes on. In the meantime, I will take some photographs. Okay. Some photograph means I will convert everything to mono. Anyway. So what do I do is I take this picture here. One. Okay. This picture is one surface, and any other surface is damaged. Okay, anyway, so from perfect of view. Okay, I'll take this surface is one. It's not damaged, but it's a design. But in our case, let's see.
So there's
okay, fine. Oh, I'll take this. Okay, fine.
yes, yes.
Close it. And then the AC key. Okay, see the code there. Epoch 1 is over with a time of 79 seconds. Okay. Now 10 epochs are going to save and leave over. Okay. Anyway, no issues. So I have taken some images. So 1, 2, 3, 4, 5 images. But my challenge is I took it in colored image. But what I need is black and white. So I will convert all the images to black and white. So first let me send this image to my email. Okay, so I am just getting the image. Okay, now second epoch you can see. Second epoch also running with visible arc. Second epoch is running with loss 8.3. Why loss is 15 there? Now the loss is 8. What happens now? Now our friend from Kilambakam. First time 330. The loss is actually, assuming the actual number is 329 for example. First time she had 330 trees. Second time it is 334. So that means which is loss is more? 329 is the exact number of trees, but first time she counted 330. Second time she counted 334. On which epoch the loss is more? Second time. But in this case here, when you go for the second time, your learning improves. Am I right? First time the learning is okay by seeing. Second time the learning improves. Now it is 8.3. 8.3 is the loss. Now let us say for all the 10 epochs. Okay. Thomas sir, wait பண்ணுவீங்கல்ல. Okay, fine. Right. Okay, fine sir. Okay. So now okay, so all these images I download it now. all the 4 images I download from my email. Okay. Now let me convert color to okay. So all these images I will convert to color to black and white. Okay. So upload image. Okay, so image 0, 1, 2, 3 is there. So image 2, convert image. Okay, it is converted. So then you download image. Then convert image, upload image 1, then convert, then download image. Okay, so upload image 0 and convert image. So then download image. Then again last one is upload image 3. So same thing, but anyway fine. Let's see. Okay, and this will be download image. So we have downloaded all the images. Image 3 modified, image 0, image 1 and image 2 modified. So we have downloaded all the images. But our training is still going on because we are in the 4th epoch. Now once all the 10 epochs are over, then our training process is completed. Okay. But in all these files, we have something called as a pre-trained model. We have a pre-trained model. Generally, either it can be referred as .pt file or .pth file. Pre-trained model file. Okay. So pre-trained model. What is pre-trained model? What is pre-trained model? So now what I am doing now is I am preparing for the, let's say I want to cook biryani. Okay. I purchase rice. I purchase either vegetables or non-veg. Means non-veg I purchase. Then I put all the ingredients. Then I am doing the preparation now. Now the preparation is going on like this. This is I am training. That means I am doing the preparation. Pre-trained model means on the way while going home, go to a shop, pay some money, get the biryani packet and go home. So this is pre-trained model. Pre-trained model means already somebody trained it and kept it somewhere. You take the trained model, put it in your model, and that trained model will make your learning easy. Make your testing easy. Okay. So now what I am doing is I am creating a pre-trained model. I am preparing a biryani, but that biryani I can sell it. If somebody pays the money, I give the biryani to you. That means if somebody asks me, I will give the PTH. So where is the PTH file? I will show you that. In my folder, it is already there. You can see. NEU ResNet 18.pth. Actually, ResNet is one kind of a model we call convolution neural network. That model. So under that we have 18 number of layers, 18 neural network layers. Please remember 18 layers. 1, 2, 3, 4 like that we have 18 layers. This is what the PTH is pre-trained model. Okay. So what I am doing now is I am training my image data set over the pre-trained model. Okay. Already somebody have a data set, somebody have a model. In that I am augmenting. Augmenting means you already know something, but let understand my images also. I am making that model to understand my images as well. Okay. So pre-trained model again the size is 45 MB. 45 MB. So 45 MB is a small size or bigger size? 44.8 MB is a smaller bigger? Huh? 45 MB in this today's scenario it is small or bigger? Small. What you can do is you can have a robot with a scanning robot. Inside the robot you put the pre-trained model into the memory of your robot. This 45 MB. Then the robot will go and take the room like this. Then, oh, there is a fault. The robot will point it. This is the project. You got it now? So now I am showing, this is a robot, my machine is going this work. But in reality, this model you take it. Leave out all the codings, images, everything. Already the pre-trained model, the robot knows. It is already there with the neural network with the weights, all the weights assigned. Take this model, put it in the robot, and run the robot in the laboratory. It will go and check it. Like this, whenever it see the wall, it will check it. Based on already the brain is already there, and check that okay there are some faults here. At the end when you come outside, you tell that 3% there are fault surface defect is there in this book. 3% is not an issue. If it is 20 to 30%, I need to take care of it. This is what we do on a deep learning model. Okay. Okay. And we will see our training. What happens to our training? Okay. I think 7th epoch. See that the loss sometimes some more and sometimes less. So 5th epoch only 2.6 is the loss. That means what? 97.7%. It is success in understanding the images. Okay, let it complete all the 10 completes. Then after that, I will run the app. Okay, we'll see that. So as of now, we have another 3 epochs remaining. So if it is a GPU, if I am having a GPU running here with a normal GPU, by this time it completes in less than 10 seconds, 10 or 20 seconds based on the GPU what we have. But since I have only CPU, it takes time. I will show you the CPU usage also. System monitor. You can see my CPU there. How many CPUs are running at 100%? You can see CPU 10, 11, 12 running with 100%, and CPU 7, 8, 9 running with 86, 51. CPU 4, 5, 6 also. CPU 1, 2, 3 also. Because all my training process uses my CPU. But if you have a GPU, NVIDIA or something is there, then you cannot see. See that? Maybe after the training, I'll show you the CPU, how it shows. After the training, let it complete. I have a 12 core CPU here. CPU 1 to CPU 12, I have 12 core CPU processor. Okay, now 8 epochs over. Another 2 epochs is pending. Okay, 8. So everything. So now the timing also you can see how much time it takes, 80, 82, 84, 80 like this. So another 2 epochs pending. Okay, 9th epoch also over. So the loss is minimal now. In the 9th epoch, the loss is almost minimal, 1.58. 1.58 is not a very big deal. 98.5%. The successful in understanding the 1 or 2 images, it's fine. But 90, but every time it takes 80 seconds. Okay. But in case of GPUs, maybe it might have taken just only half of this, not half of this, 1/10 of this. Maybe 80 seconds, it might have done 7 or 8 seconds within that. Another 80 seconds, the trained model will be done. Okay, now in the meantime, we'll check the, see that size is 44.8 MB only. Now sometimes students, when sometimes train this model, they keep it overnight and then they go. Next day morning when they come, the training process might have completed. But provided that the machine should not be powered off, the machine should be on all the time, so that the training is without any interruption, it should go on. Okay. And but if you have powerful GPUs, you can do this in less amount of time. So we have like GPUs in case if you are planning, then we have something like NVIDIA. So generally NVIDIA 4070 with 8 GB RAM. 8 GB RAM not for your computer, it is for the GPU alone. GPU also has its own RAM, its own memory and its own computation. 4070 is there. Then we call RTX 4070. Then we have RTX. Mostly, if you get 3050, I will be there with 6 GB RAM or 4 GB RAM in most of the laptops. For student laptops, that's what they will give. But 3050 also for normal work, it is fine. But if you want something powerful, then you can go with the 4070. Now, this year they have launched NVIDIA RTX 5090, which is a powerful beast. Okay, what we call. But again, the battery will, if you run on the laptop on a battery, it runs only for 1 hour, 1.5 hours if you run a GPU. But don't say that the battery is bad. Because GPUs need more power, the battery also will be consuming more. Okay, now the training process is over. See here, the total training time here is 806.27 seconds, almost 13 minutes. So with that you are waiting on a 12 core CPU. Now let me show you the CPU here. Can you see this here? Now none of the CPUs have been, mostly it is using 22, 21, 16 like this it is using. But earlier everything was clocking to 199 like that. Okay, right. Now I am going to test my application. What is the test my application? Streamlit run app.py. This is my NEU surface defect detection robust streamlit app. Okay, so this app I am going to add the drag and drop file here. Okay, now browse the file. I use image 3 modified. What is image we do not know, but this is the image. Okay, how it shows you. Now top 3 predictions. So crashing is 45.93 and patches 31.54, scratches 13.05. Correct now? Maybe it's correct, right? So that means what? All these things are equally possible there. All the 3 kinds of, at this location, because maybe because of the leakage there in from the AC, and possibly that is there. Okay. Now, please remember, the surface defect is common in concretes. We do not bother. Even our house also we have cracks. We don't feel. Okay, fine. Let us not bother about it because cement has the properties of cracking after a period of time. So not an issue. But in industrial system, inside a boiler, inside a manufacturing thing, if a defect comes, the entire quality of the product will be getting damaged. Okay, in that case, they have to be very careful about it. That's why we have this. Now, this is one image, and you can download this probabilities also. What probabilities for this? Okay, number of classes is we have only 6, but if you want to reduce the number of classes, you can reduce to 5, reduce to 1 also. That means whichever is the highest probability, that value will be shown here. Okay, now this is what this. Now next one I'll check it. Image 0, this maybe this location. Oh, this also same 44. Okay, fine. Now next one is image 1. This image, that image 1. Now it is selling rolled in scale. Rolled in scale is this, crashing is this, patches. But actually there is a design, but I should not have taken it. But anyway, if it is a normal, pure, complete good wall, but what would be the patches available in this location here? Okay, so this is what here. Now rolled in scale have a highest probability, prediction is more. Then accordingly you can see that because rolled in scale is what? Everywhere there are lines over there. So it is showing that rolled in scale here. Okay, right. Now next to final one is browse files, and we have last one is this image. Only one rolled in scale, because you can see everything is rolled in scale only as per the image. Got it now? See, now please remember my input data is 1440 images, categorized into 6 categories. Okay, 1440 is a bigger number or smaller number? It is a smaller number. So if you have 1,40,000 images, it's a bigger number. That means, I am comparing the fault, the defect against 1,40 images on the trained model is fine. But 1,140 is, the model is trained for only 15 minutes. You are predicting this is what my defect in my room. How can we believe on you? That's correct. But for a demo in 1 hour, this is what I can do. Okay, na? So this is actually a project. This is actually a project. This work what I am doing is your BTech project, or we can call a MTech project also. Okay. So what we did is actually I am running this on the browser. I am doing this on the app also. I create a mobile app with the same look and feel screens. You can see. Yeah, this is my mobile app. I can have a mobile app like this. I can upload the image here, and then right away I can give the image from here. But only challenge now is it is in white and black. But if you have a colored image also, for that you have to train the model also in color. Please remember, white and black color, how many variables you need have? Only one variable. 0 means black, 1 means white. The absence of darkness is, the absence of light is darkness. That's what the statement. Okay, white, black and white is only one color. If the color is present, it is white. If not present, it is black. But what about for colored image? Colored image, 3 colors. What are the 3 colors? See, generally when we see the pixels is 48 cross 1. This is 48 pixels x-axis, 48 pixel y-axis, and 1 is white and black. For colored image, the same colored image, 48 cross 3. Why 3? RGB or YCM. So RGB means red, green, blue. YCM is yellow, cyan, magenta. So either these any of this coloring, but mostly we go for RGBs. Or for medical applications or some kind of special application, we go for YCM. Okay, but RGB was very common applications. Okay, so this is what we can able to detect the detection. Okay, fine. So any queries, because it's almost 10:25. But anyway, 1 hour it's okay now. Giving a basics intro and then with a probable demo. And let me stop it here.